Parallel beam of monochromatic light of wavelength 663 nanometer is incident on a totally reflecting plane mirror. There is a plane mirror which is completely reflecting. Okay, whatever light is incident on it, that is reflected. Let us suppose that is the mirror. Here is the mirror, and light is incident in this mirror like this at theta is equal to 60 degree. Okay, let us suppose number of photons falling per unit time is dn upon dt. The angle of incidence is 60 degree and the number of photons is striking. This value is also given to be 1 into 10 to the power 19. Calculate the force exerted by the light beam on the mirror. So let us suppose this light is reflected back. So the photo that momentum, if you write the momentum of photon is given to be h by lambda, and so the force is created by the vertically change in momentum. So this is h by lambda. So here also will be h by lambda. But the thing is that only vertical change in momentum is going to create the force. Okay, now so that's why the initial momentum, if you write in vertical direction, in normal direction, you will write what h by lambda, that is the cos theta, and final momentum in vertical direction, that is h by lambda. So the reason is that this is lambda is a vector, that momentum is the vector quantity. So we'll write this. This is downward here. We'll write the change in momentum, that is delta p. So h by lambda cos theta minus h by lambda cos theta. So you can write this h by final momentum minus initial momentum cos theta. So you can write this is 2h by lambda cos theta. So this is the change in momentum of one photon only. That is change in momentum of one photon only. If you have to the change in net change in momentum per unit time, so you have to multiply the number of photons falling per unit time. So that is nothing but the what force. Force is what delta p if you multiply dn upon dt. So that is the total momentum. Because this is the number of photons and dt is what the time. So change in momentum per unit time is what force. Is it or not? So you see, you can write 2h by lambda and dn upon dt. Its value is given to me here, 1 into 10 to the power 19. But remember that this is what cos theta here, and this is 1 into 10 to the power 19. That is the value of number of photons falling per unit time. That is given to be 19, I hope. Yes. So put all the values here. You will find the force acting. So I'm writing 2 and h value is 6.64 10 to the power minus 34 divided by lambda. Lambda value is given to be here. That is given to be 663. 63 nanometer. Nanometer 10 to the power 9. And cos theta, cos that is cos 60. So cos 60 value is 1 by 2. This is 1 into 10 to the power 19. So you see, just we have to calculate this, we'll find the force. So you come here, if you make this 664, it will take 10 to the power 2 from here, so it will be 10 to the power 17. So you can write 2 into 664. Okay, and that 17 and this will be subtracted, that will 10 to the power minus 17 like this. Okay, now the remaining thing you see here 663, and that is 10 to the power minus 9. So this got cancelled, and here is 1 by 2. So you have to take this 1 by 2. So that 1 by 2 1 by 2 be cancelled. So you erase from here. Now you see f, that is 10 to the power minus 17 and plus 9. So you will be remaining with 10 to the power minus 8 Newton. So that is the force exerted by the light on the surface. Thank you for watching.